Welcome to the deep dive. I'm your host, and today we are unpacking a really incredible set of sources.
Yeah, I'm super excited to be here and jump right into this one.
We have a lot to cover. We're looking at a huge stack of historical documents today, patent filings, old scientific journals, biographical notes, and our mission here is to figure out the truth behind one of the biggest tech scandals of the early 20th century.
A scandal that, frankly, most people don't even know happened.
Exactly. So to start us off, I want you to picture a scene. It is essentially the moon landing moment of the 20th century, but it happens in 1901. We are on a freezing, windswept hilltop in Newfoundland. It's called Signal Hill.
Right, it's December 12th. The weather is just absolutely atrocious.
Oh, totally miserable. And huddled inside this abandoned barracks is Guglielmo Marconi. He's young, he's ambitious, and he is about to become the most famous man on the planet.
The stakes literally could not be higher for him in this moment.
He's sitting there with a telephone receiver pressed against his ear. He's listening to static, listening to the wind howling outside, and he's waiting for a signal from Cornwall, England, which is 2,000 miles away across the Atlantic Ocean.
And we have to remember, most of the scientific community at the time said this was completely impossible.
Because they thought radio waves traveled in straight lines, right?
Right.
Like light.
Exactly. They believed the signal would just shoot off the horizon and get lost in space. Marconi was betting his entire reputation that the waves would somehow hug the curve of the Earth.
And then, at 12:30 p.m., it happens. Click, click, click. 3 sharp dots. The letter S.
The very first transatlantic wireless signal. I mean, the world effectively shrank overnight.
It's the standard textbook story.
Yep.
Marconi is the hero. He's the solitary genius who conquered the ocean. But here is where we are going to start pulling the thread. Because the documents we're analyzing today suggest the story isn't quite that simple.
Not at all.
We're specifically looking at the device Marconi used to actually hear that signal.
The ears of the operation, so to speak.
Exactly. What if I told you that the technology Marconi used to hear those 3 dots didn't actually belong to him? And it wasn't invented by the Italian Navy, which is what the newspapers claimed later.
It's a huge twist.
It really is. It was actually the work of a physics professor in Calcutta, India, who was operating on a completely different frequency, literally and metaphorically.
Today we are talking about Sir Jagadish Chandra Bose. Honestly, calling him a radio pioneer almost undersells his genius. He was doing things in the 1890s that shouldn't have been possible.
We're talking about a guy who was effectively building the components for modern 5G networks and radar systems on a wooden table in Victorian India. So let's dive into the hidden frequency. Who was J.C. Bose?
J.C. Bose is one of those figures who bridges 2 entirely different worlds. He was born in 1858 in the Bengal Presidency. He went to Cambridge, he studied under Lord Rayleigh, who is an absolute titan of physics, and then he returned to Calcutta to teach at Presidency College.
But to understand why he matters to Marconi's story, we sort of have to understand the Wild West of radio in the 1890s.
That's a great way to put it. The scientific community was basically split into 2 tribes back then. On one side, you had the electrically minded camp.
This is Marconi, Tesla, the telegraph engineers.
Right, and their philosophy was basically brute force. They wanted to send messages over huge distances. So they built massive antennas, they used huge sparks, and they focused on low-frequency, very long waves.
The whole go big or go home crowd. They wanted to build a business and replace the telegraph wire.
Exactly. But then you had the other camp, the optically minded camp. This included Bose, Heinrich Hertz, and Oliver Lodge. They weren't trying to build a startup, they were just trying to understand the physics of it all.
They wanted to prove that these invisible electric waves behaved exactly like light beams, that they could bounce, refract, be focused.
Precisely. And if you want to study how a wave behaves in a lab setting, you can't use a wave that is a mile long.
You need something tiny.
Yes, and this is where Bose went completely rogue. While Marconi was using waves that were hundreds of meters long, Bose went the exact opposite direction. He started generating millimeter waves.
Wait, let's pause on that for a second, because millimeter waves is a buzzword we hear all the time in tech news today. We're talking about the EHF range, right? Extremely high frequency.
It is. That is the exact spectrum used for modern 5G networks. It's used for collision avoidance, radar in your car, airport security scanners, all of that.
And Bose was generating and manipulating these waves in 1895.
He was effectively doing modern microwave physics a full century ahead of schedule.
Which brings us to his famous demonstration at the town hall in Calcutta in 1895. The sources describe this almost like a magic show. What exactly happened there?
It did look like magic, but it was pure, rigorous science. The lieutenant governor of Bengal was in the audience. Bose set up a transmitter and a receiver about 75 feet apart.
Which, okay, compared to the Atlantic Ocean, 75 feet sounds like nothing.
True, but distance wasn't the point of this experiment. Penetration was the point. He sent the waves through the body of the chairman of the meeting, through 3 solid walls, and into a completely closed room.
And what happened in the room?
When the waves hit the receiver, they had enough energy to trip a heavy relay. That relay rang a bell and remotely fired a pistol.
He fired a gun through a wall using radio waves.
Yeah.
In 1895.
It was absolutely spectacular. He was proving that electromagnetic waves could pass through physical obstacles, which is the fundamental concept behind everything from your home Wi-Fi to ground-penetrating radar.
What I really love about this deep dive, though, is looking at his gear. Bose didn't have a massive industrial laboratory. He didn't have a blank check from wealthy investors. He was building this stuff himself, and some of it is pure MacGyver engineering.
It really is. Because he was working with such tiny wavelengths, we're talking 5 millimeters to 2.5 centimeters, he had to invent entirely new components. Standard wire antennas just wouldn't catch waves that small.
So what did he do?
He built what he called a collecting funnel.
Which, looking at the patent diagrams in our sources, it looks exactly like the things I see strapped to cell towers today.
That's because it's a pyramidal horn antenna. If you look at a microwave feed or a modern satellite dish, you are looking at the direct descendant of Bose's funnel. He basically invented the standard way we catch microwaves today.
But my absolute favorite detail, and this just screams resourceful genius, is the polarizer. He needed a device to filter the waves so they only vibrated in one specific direction, and he used Bradshaw's railway timetable, a literal train schedule.
It was perfect for the job. He realized that the pages of that specific book were compressed in a very uniform way, so he interleaved sheets of tinfoil into the pages to create a metal grating.
That's brilliant on its own.
But then he discovered something even wilder. He found that even without the tinfoil, the paper pages themselves had a fiber structure that could polarize the millimeter waves just because of how they were stacked and pressed together.
So he turned a paperback train schedule into a high-precision optical instrument.
He did. And he used that understanding to build other optical devices for radio, like the double prism attenuator.
How did that work?
It was 2 prisms with a tiny variable air gap between them. By adjusting that gap, he could tunnel the signal through the air to control the volume of the signal. It was essentially quantum tunneling before we even had the vocabulary for it.
And I read in the notes that this specific prism design isn't just some museum piece, it's still being used.
Oh, absolutely. The National Radio Astronomy Observatory, the NRAO, uses Bose's exact double prism design at their 12-meter telescope in Arizona right now.
That's wild.
When they need to calibrate their millimeter wave receivers to look at distant stars, they're using a design Bose sketched out in 1897.
Okay, so Bose is clearly a wizard of hardware. But we need to get to the crime scene, the transatlantic signal. To understand why Bose is involved in Marconi's big moment, we have to talk about the coherer.
Right, the coherer is the detector. It's the ear of the radio system. In the 1890s, the standard technology, which was used by Oliver Lodge and initially by Marconi, was the filings coherer.
Picture a glass tube filled with loose metal filings, like iron dust.
Exactly. Normally the dust is loose, so electricity can't flow through it. It acts as an open circuit.
But when a radio wave hits it,
the dust particles get magnetized, they clump together, or cohere, the circuit closes, the current flows from your battery, and your machine goes click.
Simple enough. It's like a switch that turns on when a radio wave hits it.
Ouch.
But there's a massive problem with this design, right?
A huge problem. Think of those filings like Velcro. Once they stick together, they stay stuck. The circuit stays closed.
So you can't hear the next dot or dash because the device is permanently jammed in the on position.
Exactly. So how do you fix that? You have to hit it, literally. They built these little automatic hammers, kind of like the clapper on a mechanical bell, to tap the glass tube after every single signal to shake the filings loose.
Click tap, click tap.
Yes. It was incredibly clumsy, slow, and noisy. But for Marconi at Signal Hill, the problem was fatal.
Because he's trying to hear a ghost of a signal from 2,000 miles away.
Right. It is way too weak to trigger a heavy Morse code printer. He has to use a highly sensitive telephone receiver held right to his ear to hear it.
And you definitely cannot use a mechanical hammer with a telephone receiver.
No. The physical tapping would completely deafen you, and the noise would drown out the tiny whisper of the signal. To use a telephone, Marconi desperately needed a detector that was self-recovering.
Something that would conduct when the wave hit and instantly reset itself the moment the wave stopped. He needed a spring, not Velcro.
Enter J.C. Bose.
Enter Bose. Because in 1899, Bose presented a paper to the Royal Society in London, and he had developed a completely new type of detector.
It wasn't filings at all. It was a U-shaped tube filled with mercury with an iron plunger on one side, the iron-mercury iron coherer.
And how did that solve the Velcro problem?
Bose discovered that the interface between iron and mercury was incredibly sensitive to radio waves. But crucially, it was elastic. The electrical resistance would drop instantly when the wave hit, and the moment the wave stopped, the resistance shot right back up.
So no sticking, no hammer needed.
No hammer, it was totally instantaneous. And Bose explicitly described in his paper hooking this exact device up to a telephone receiver and hearing the signals clearly.
He even called it an artificial retina.
Because it reacted so fast, just like a biological eye reacting to a flash of light.
Okay, so let's look at the timeline here, because this is where the sources get really intense. Bose demos this in London in 1899. It's published in the Proceedings of the Royal Society. The whole scientific community sees it.
Yep.
Fast forward to December 1901. Marconi is in Newfoundland. He hears the S. He comes back an international hero. When do people start realizing something doesn't add up about his equipment?
Almost immediately. The technical community knew perfectly well that the old filings tube couldn't work with a telephone receiver. Marconi was incredibly secretive about what he actually used on that hill.
And initially, he claimed it was the Italian Navy coherer.
Right. He said it was a gift from his childhood friend, a lieutenant named Luigi Solari, who was serving in the Italian Navy.
Which implies the Italian military invented it. But then the scandal breaks.
In May 1902, Professor Angelo Banti, who was the editor of a major electrical journal, published a massive expose. He said, look, the Italian Navy didn't invent this device. A signalman named Castelli just assembled it based on other people's designs.
Yeah, Marconi panicked.
He absolutely panicked, and we have the receipts for this. This is where it gets highly forensic. In September 1901, which is months before the transatlantic test even happened, Marconi had quietly applied for a patent in his own name for a new detector.
Let me guess the description.
A drop of mercury between iron or carbon plugs.
Which is Bose's exact design.
It is mechanically identical to Bose's design. The only difference is that Solari had straightened Bose's U-shaped tube into a straight glass tube. That is literally the only modification.
Wow.
When Banti blew the whistle in the press, Marconi was forced to legally amend his patent application. He had to change the official wording to say the invention was communicated from abroad by Solari.
Communicated from abroad. That is a very polite legal euphemism for my friend copied it.
And the connection is crystal clear. Solari had attended the scientific conferences in London. The specific combination of iron and mercury isn't just some random guess. It's a highly specific chemical interface that Bose spent years perfecting to get the voltage curve just right.
The idea that Solari just stumbled upon the exact same chemical solution by accident is highly unlikely.
Really extremely unlikely.
So, did Marconi ever admit it? Did he ever publicly say, hey, thanks to the work of Professor Bose, I was able to hear the signal?
Never once. He cited the Italian Navy, or sometimes he cited David Hughes, who was an older scientist from before Hertz's time, but he never credited Bose.
That's brutal.
And later, Marconi even tried to downplay the device entirely, saying it wasn't reliable for commercial work. But the historical fact remains, on that day, December 12, 1901, the only reason Marconi heard those clicks was because of that mercury detector.
That is just staggering. The most famous moment in radio history, the literal moment the world changed, relied entirely on a piece of tech lifted from a scientist in Calcutta.
And here is the real kicker for you. We keep calling it a coherer, because that was the terminology of the day. But Bose had actually invented something far more important without anyone realizing it.
What was it?
He had invented the semiconductor diode.
Wait, break that down for me. Like the diodes we use in modern computer chips.
Exactly like that. A diode is basically a one-way valve for electricity. It converts the alternating current of a radio wave into a direct current signal that you can actually hear in a speaker or a phone.
Okay.
Bose found that the contact point between the metal and the semiconductor material, he also experimented heavily with galena crystals, had a very specific behavior.
You're talking about the knee voltage mentioned in the sources.
Yes. He identified that at exactly around 0.45 volts, the current suddenly starts to flow. That behavior is exactly how modern solid-state electronics work. Bose even patented a point contact detector in 1904.
So he was effectively the first person to use a semiconductor to detect a radio signal.
Decades before it became the standard in electronics.
So if we look at the historical scoreboard here, Bose has the first horn antenna, the first semiconductor patent, and the receiver that likely enabled the first transatlantic signal. Why isn't this guy on the $10 bill? Why isn't he a household name?
A lot of it really comes down to his personal philosophy. Bose was not a businessman. He was deeply, fundamentally anti-commercial. He believed that scientific knowledge should be completely free.
He was doing open source before open source was even a thing.
Truly. He refused to patent many of his early inventions because he wanted other scientists to be able to use them freely to advance the field. He explicitly wrote that he wanted to avoid the commercial spirit of the age.
While Marconi was out there building a global monopoly and suing anyone who even breathed on his patents.
Exactly. And by the time the patent wars really heated up, Bose was already getting bored and moving on to the next scientific mystery.
And speaking of moving on, he didn't even sneak in radio, right? This is the part of the sources that really confuses people. He pivoted his entire career to plants.
It seems like a completely hard left turn, but if you look at his underlying logic, it makes perfect sense. He just applied his deep knowledge of radio waves to biology. He started treating plants like they were receivers.
What does that mean exactly? Like treating a plant as an antenna?
Kind of. In one experiment, he placed a transmitter 200 meters away from a plant and just blasted it with radio waves. And he discovered that feeble signals actually accelerated the plant's growth, while strong signals stunted it.
So he was studying the biological effects of electrosmog in the early 1900s.
He was, and he went even further. He proposed that plants actually have a nervous system.
Which sounds completely crazy for the time.
Oh, the scientific community definitely thought he was drifting into mysticism. But Bose built these incredibly sensitive instruments, using his clockwork and optical engineering skills, to physically measure the electrical pulses inside plant stems.
He was measuring their electrical signals.
Yes. He argued that plants feel and react electrically to their environment, just like animals do.
And I assume the biologists of the era just dismissed him.
They did. But fast forward to the 1990s, and modern biophysicists like Wayne and Pickard actually confirmed his theories. Plants do use electrical signaling action potentials to react to their environment.
Once again, Bose was about a century early to the party.
It is a massive recurring theme with him. He's always arriving at the destination way before the rest of the world has even packed their bags.
It really is.
He just didn't see walls between disciplines. To him, a metal wire conducting radio waves and a plant stem conducting a biological signal were just two different materials moving energy. He looked for the unity in everything.
So let's bring it back to Signal Hill to wrap this up.
Right.
When we think about Marconi, the kite in the wind, the cold, and those 3 clicks, how should we reframe that story based on what we've learned today?
I think we still have to give Marconi credit for the sheer scale of his ambition. He had the audacity to try something everyone else said was totally impossible. He proved that radio could span the globe. And that is a massive achievement in engineering and sheer vision.
But the technology itself.
The technology that made the signal audible. The actual interface between the invisible wave and the human ear. That was the genius of J.C. Bose. Without that specific piece of MacGyver science, the mercury diode Marconi might have just been sitting in that freezing barracks listening to dead silence.
It really makes you wonder about the what-ifs of history. If Bose had been a little more like Marconi, if he'd hired a PR team and a Shark Tank of lawyers.
We might be talking about Bose telegraphy today instead of Marconi. We might have had the semiconductor revolution kick off in the 1910s instead of the 1940s. The entire technological timeline of the 20th century could have dramatically shifted.
That is a mind-bending thought. We potentially lost decades of progress just because the inventor didn't care about getting the patent.
And I'll leave you with one final nugget from the files that genuinely keeps me up at night. Back in 1897, Bose was trying to detect radio waves coming from the sun.
And did he succeed?
He failed. He couldn't detect them. But he wrote in his notebook that he suspected the solar or terrestrial atmosphere was acting as a shield, absorbing the waves before they hit his detector.
And was the atmosphere absorbing them?
Yes. He had basically stumbled upon the 1.2 centimeter water vapor absorption line. This is a massive concept in radio astronomy that wasn't officially confirmed until we developed advanced military radar in 1944.
And he predicted it in 1897.
He predicted it simply because his silence told him something was there.
That is incredible. It really begs the question for you to think about what other lost insights are just sitting there, hiding in the notebooks of scientists who just didn't care about the fame.
That is the hidden frequency. You just have to know how to listen for it.
Well said. Thank you for joining us on this deep dive.
Always a pleasure.